Okay, so I'm going to go ahead and get started. Uh, would it be possible for you to move a little bit so that I don't like lose sight of you, so that I can, yeah, so I guess I could move too, but thank you, I appreciate that. Okay, so I don't want y'all to freak out when you see this diagram, either those of you here or anybody watching this online, because you have freedom to design your project, in your own way. So if you already have your state diagram, chances are your state diagram is just fine. The reason I changed mine a little bit is last time we met, there was someone, I don't think it was anyone here, who was asking me about, well, what about like if it stops in between floors or something? I can't remember exactly the way he put it, and I kind of blew him off and said, "Oh, no, I don't do that. If I'm in the elevator, it's going to go where I want it to go." And then I realized, well, wait a minute. If I get on the elevator on floor 1 and press floor 3, and then someone else gets in at floor 2 and presses floor 1 and goes back to floor 1, I'm going to be mad. Now, you don't have to consider that in this project. This is not part of what you have to do, but I decided for fun that that's what I was going to do. And so I considered all of these different possibilities. And so you don't have to do this, but I'm going to tell you what I did. And regardless of how I did it, the way you're going to do it, the techniques that I'm going to talk about will still help. So the way I thought about it was like this. I thought that so I just added a few more details. And so if I'm on floor 1 and I get to floor 1, then the door is open. And it has to stay open for 2 clock cycles. So the next thing I'm going to do is, this is floor 1. Next thing I'm going to do is I'm going to go to, I decided to make another state where the door was still open and I was still on floor 1, but now I could go somewhere. So based on what switches were pressed at this point, I could go somewhere if I wanted to. If I'm just at the first stage, the only thing I can do is go to the second stage. There's nothing else I can do. But if I just sit here on floor 1, then, and this is something I hadn't thought about before, but if I just sit there on floor 1, the door should close and it shouldn't go anywhere. So I decided that I should really have 3 stages in floor 1, with door open and going to the next stage, and then door open, and then the door closed. And then I said, well, what's going to happen next? Well, if I choose to go to floor 2 from either this stage or this stage right here, if I choose to go to floor 2, then I should go to floor 2 with the door open. And the same sort of thing should happen on floor 2, that if it always has to go to the next stage because it has to be there for 2 times, but if nothing happens, it could go to where the door was closed. But what happens if I'm on floor 1 and I decide I want to go to floor 3 and not stop at floor 2? So this is something I hadn't done in previous years, and it never mattered. So it doesn't, and people who based their code on mine, it didn't seem to matter to them either. So it's not something you have to do. But I decided if I'm going to go to floor 3, I should, and not stop on floor 2, I should go through floor 2. So my next clock cycle should be floor 2 with the door closed. And then my next clock cycle should be floor 3. So from floor 1, I should go to floor 2 with the door closed, and then to floor 3. But then, what happens if I say I'm going to go to floor if I'm on floor 1 and I just say I have floor 2 and floor 3 switched, so they're both on. Well, then I would say you definitely go to floor 2 first, no question about that. And that's usually where I've left it. And then at that point, just reevaluate, start over. This is where I did something a little bit different this year just for fun. And I said if floor 2 and floor 3 are both pressed, then if I get on floor 2 and then someone also then turns on floor 1, I don't want to go back to floor 1. I want to keep going to floor 3. So I added 4 more states. I added floor 2 going up, stage 1, floor 2 going up, stage 2, floor 2, and then the same thing going down from floor 3, going down, stage 1, and floor 2 going down, stage 2. So I added those additional states. You don't have to add those if you don't want to. So it just something that I did. So just to show you why I have so many states when I go to the coding. So any questions at this point before we go on to the coding? Because I think we've talked about the state diagram in previous sessions. Any questions on the state diagram? Everyone kind of feel like they have their state diagram set? Okay, so when the reason I changed it so much is that when I started coding, I tend to try to make things as compact as possible and say, okay, well, I'm just gonna have like 3 states and try to have everything based on that. And then I decided that probably is not the best way to go about things. It's probably a little easier to not try to combine states. So I was going to try to combine states and have things like, did I stop here, or am I going up or going down as separate variables? And I decided just to make sure that I had a bunch of different states. So I'm going to show you the technique that I chose. It's not finished, so even if you think you're going to say, aha, I'm just going to screen capture everything that we have here and just do this, it's not going to work because it's not completely finished, but it will show you the idea of what's going on. So because I'm lazy, I've mentioned this before, I did not change the names of the constraints. So in my constraints, these are the same constraints you're supposed to have. So I like to use this little extra module here because the button on it doesn't double click. So this is available in the lab if you want to use this one, and that's the code for using this as the clock is right up there. So it uses that as the clock, and if you just say you want the extra button module, and it plugs in to, if you're looking at the basis board, the top left and the top row, and the button is the bottom right button. So that's the button. And that's the code for that. The other things you're supposed to use is you're supposed to use switches 1 through 4. For switch 1 is to call floor 1, switch 2 is to call floor 2, switch 3 is to call floor 3, and switch 4 is to say the door is blocked. And so in my laziness, I just said, I'll just copy those and just use those as my variable names. But you could call these floor 1 and floor 1 switch and floor 2 switch and door block or whatever, but I'm just much too lazy to make my code readable. Okay, and then you are also supposed to use the LEDs. And the LEDs are supposed to show what floor you're on and if the door is blocked, if I recall correctly. And if I believe it was supposed to be LEDs 7, 8, and 9. So 7 would be floor 1, 8 floor 2, 9 floor 3, and 10 to show if the door is blocked. So these are exactly the same constraints that you should have, just perhaps with different variable names. But for a brief moment, I said, oh, wouldn't it be cool to also have the 7-segment display and have it display what floor you're on? And I thought about putting that in, and I probably will before the semester's over, but I didn't want to do it for this session, because then I thought that might be too much in the code and might confuse people. But yes?
Do you think it's like too much extra work with like, the time you have left to add it on, or is it like a very reasonable thing to do?
I think it's really not that hard. Because if you have everything else set, it's just adding just one more little thing, and I'll show you where you would add it. Okay. So the first thing you would have to add is the constraints for the 7-segment display, which y'all used that in the previous lab, right? Yeah. Okay, so I just had SW as my input, and I had it as a vectored signal. I keep them as a vectored signal because it just makes it easier for me to access them, but you might have these as separate variables. So what this is saying is, if you look at my code, that switch 1 is floor 1 switch. So if I treat them individually, switch 2 is floor 2, and switch 3 is floor 3, and switch 4 is door blocked. And similarly for my LEDs, I have that LED 7 indicates on floor 1, LED 8 indicates on floor 2, etc. And the way I use these is I set them all at once. So when I'm setting these, I'm going to set LED equal to, or actually I'm going to do next LED. So depending on my conditions, I'm going to set them all at once, and I'm going to do 4B 0101 means on floor 2 with door open. So that's the same thing as saying, like if I had a floor 2 LED, so this is equivalent to floor 2 LED equals 1 door open LED equals 1. So if you had like different variables, so I just set them all at once. I set all my LEDs at once, just to be lazy. And then because my experience tells me that when I have a finite state machine, the best way to do it is to have 2 always blocks. One always block where I figure out what my state and next state are, and one always block for actually changing states. Then that's why I have LED and next LED and state and next state. And this, I'm surprised it was working earlier, because my state is now 3 or 4 bits wide. And then I had the 4 to 1 and the 10 to 7 just to match the constraints. And then to make it easier to read, I did put in parameters for each state. So for every state that I had, I gave it a number. And so I had enough states that I needed 4 bits. You might not, you might only need 3 bits, but you need to, if you use parameters, then you would set them up here at the beginning. So just have a different number for each one. So any questions on the setup here before I get going with, the actual implementation of the code? Everybody good? Okay, so I have one always block that will change anytime there's a change in state, and I probably need to change this change in state and also switch, because anytime the switches, I needed to have that too, because if the switches change, it should also occur. Now, your setup is probably going to be similar to mine. You just might have different if statements. So I have always at state and switch, and then I have begin. And then my always block, I have all of my decision making, and then end. So they always will have a begin and end. I don't need a begin and end, because the only thing in my always block is one big case statement. There's a lot of stuff in the case statement, but it's just one big case statement. And the case is based on what state am I in right now. So I look at what state I'm in right now, and then I look at what switches are set, and then from that I determine what my LEDs should be and what my next state should be. And some states are easier than others. So like for instance, if I'm on floor 1A, then the only thing that I can do, regardless of what the switches are, so floor 1A is like my first clock cycle on floor 1, the only thing I can do is go to floor B. And it doesn't even matter if the door is blocked, because the door is going to be open, the door is going to stay open. And so I just set the LEDs to be that I'm on floor 1 with the door open. So this is the first one here is 1 for floor 1, and 0 for floor 2, and 0 for floor 3, and 1 because the door is open. And then I say my next state is floor 1B. And that's all I have to do for that one. But then when I get to floor 1B, this is where I have lots of decisions to make, and your decisions may be different than mine. So what I decided, the way my elevator works, is if I'm on floor 1B, if someone presses the floor 1 button, I decided this is new for me too. I decided pressing the floor 1 button is kind of like pressing the door open button. So I decided if you press the floor 1 button, you stay on floor 1. You stay where you are for the next clock cycle. You don't have to do that if you don't want to. You might say, if you press the floor 1 button, well, tough, you're already on floor 1, I'm ignoring it. That's what I've done in previous years. But I said, if you press the floor 1 button or the door blocked button, then you're just going to stay exactly where you are. You're going to stay on floor 1B, and so your LEDs are going to be the same. And then I said, well, where it gets tricky for me is with the switch 2 and 3. And at first I did these with a series and if and else, if and else and if else and all that. And then finally I decided just to do it as a case statement that based on switch 2 and switch 3, but you could do it as if statements if you wanted to. So here I have switch 2 and switch 3 in a case statement, and so I put the curly brackets to put them together. And this is saying if they're both 0. So remember that if switch 1 or switch 4 was activated, I already did something. So those are out of the question. So now, neither one of those both have to be 0 or I'd never get here. So now I'm saying switch 2 and switch 3 are both 0. So in that case, I'm going to go to floor 1C, which is floor 1 with the door closed. So this is basically saying if all the switches are off. This is the same thing as saying if all the switches are 0, or saying, like I say in some other places, if saying if switch equals 4B000. So that's the same thing as saying that. So this is saying that if all 4 switches are off, then I'm going to stay where I am on floor 1, but the door is going to close. And then the next thing I say is, well, if switch 2 is at 0 and switch 3 is at 1, then the next place that I'm going to go is floor 2 with the door closed. Now, in previous years, I just went straight to floor 3. So this is saying switch 2 is 0, so it's switch 1 is 0, switch 2 is 0, switch 3 is 1, and switch 4 is 0. So you just have switch 3 is set. And so I'm saying the next place you have to go is floor 2 with the door closed, because to get to floor 3, you have to go through floor 2. In previous years, I just skipped that part and went straight to floor 3. So that's what I have here. This is floor 2 with the door closed. And then I said, well, if you have floor 2 and not floor 3, then the next place you go is floor 2A, the floor 2 with the door open at the beginning. And then here's where I got all fancy. And I said, well, if you have both 2 and 3 set, then the next place you're going to go is to my new state that I have floor 2 going up, because you have 2 and 3 set, so you're going up. So this is more fancy than you need to be. You were not required to do this in your project. So if you want to put it in, you can. If not, I would just say, do the same thing. If I would probably have it cascaded as originally as if floor 2 do this, else if floor 3 do this. Yeah.
Is it a bad thing for it to be simple? Like, will it be looked at as more lazy?
No, they probably won't even notice, because usually the way they do this is they say demonstrate your project. And so you'll say, okay, well, here's how it works, and you show and you demo it. And then they say, okay, now try this out. And they'll give you like a set to do. And it's usually something basic. They're usually not checking to see, did you account for if you're on floor 3, it's so I wouldn't worry about that. Okay, so that is the showing you, let's see, so that was floor 2, or floor 1, floor 1B. In floor 1C, this new set that I added, which has the door closed, is going to be very similar to floor 1B, because the switches that you set, if you're going to 2 or going to 3 or staying on 1, it's all going to be very similar. The only thing that I changed is I said, if you're on floor 1 with the door closed and you press the floor 1 button, like if I'm in an elevator and I'm sitting at floor 1 and I want to get out, well, I'd probably press the door open button. If that doesn't work, I'd probably press the floor 1 button. So I have that if you're on floor 1 with the door closed and you press the floor 1 button, you go back to floor 1B. But that's, other than that, I think it's pretty much the same. So floor 1C. I thought I did it. Maybe I didn't do it. Oh no, here it is. It just looked the same. It looked the same as floor 1B because it is practically the same. So if switch 1 or 4, then I go to floor 1B. And then if all the switches are 0, I stay where I am. And then I have that case statement. So then what I do is I go through with each different state and I figure out, well, what do I want to do in each case? And so you do want to make sure that you have everything covered, because if you skip anything, like if there's any possibility that you might have left something up in the air, like this could happen and you didn't account for it, then Verilog is gonna give you an error. So like with floor 2A, I don't have any ifs or any cases or anything. I just say, do this no matter what. And so I don't have to worry about covering every eventuality. But with floor 2B, I do need to make sure that, what I really need to make sure that I do is I have a default. Because if you have a default, then you're set if, even if nothing, if you didn't cover it. And so you need to make sure, especially like for me, I didn't cover, like not all of my possible 4 bits have a state assigned to them. So you do have to make sure that you have that covered. And you do want to make sure that, like, something, it knows what to do, or if it doesn't know what to do, that staying where it is going to be fine. So floor 2B, I have if switch 2 or 4 is set. So if switch 2 or switch 4, you do that. Else if all the switches are 0. So now I've taken care of they're all 0, or if 2 is on, or if 4 is on. So the only other possibility that I have is if 3 is on. Else if switch 3. Oh no, that's not true because I could have 1. Else if switch 3. And then I just have an else. I mean for this else to be for switch 1, but I just put else, and that way I know that Verilog's not going to yell at me because it covers all the possibilities. So I have all the possibilities for all the different states, what should happen. And so even if you're going through this and you're doing the screenshots, you're not going to catch everything because I have some floors that aren't covered. So I've got those commented out. And if you do this, you'd have to figure out what you're going to do for those floors. So if you copy exactly what I do, you still have to figure these out. So floor 2 up and floor 2B down. So those are not done. But you do want to make sure you have a default. You could make these don't cares. I put something in there. I said I wanted my default to be to go to floor 1 with the door open. Or that's what I meant to put. And so that is the logic. So the logic is, while it seems like it's complicated, yours, it's just because I went kind of crazy. It really should just be case, state, and then whatever you call your states, floor 1A, begin, and then within this, you're either going to have a case statement based on your switches, or you'll have a series of if and else, or if else. And so based on what the switches are, you'll have that, and you'll set what you want your next state to be. And what you want your output to be. And my output, I just called that next LED. And so for each state, you're going to have your conditions. If it's this condition, do this. If it's this condition, do this. And for each condition that you come up with, you're going to tell it what the next state is and what the output is. So if you're wondering what conditions we're talking about, your only conditions that you have are your 4 switches. So your conditions have to do with, switch 1, switch 2, switch 3, switch 4, and you need to determine what to do for each of those switches. And how much you do for if multiples of them are on is going to be up to you with your design. So you're going to have, if switch 1, do this, if else if, do this, or you might have a case statement. So that's your main logic. You know, I know some of you would like me to tell you exactly what to do, but I can't do that because this is your project. But I've given you as much guidance as I can. And then the last part you're going to have is an always block, and your always block, your second always block, and your second always block will be on the positive edge of the clock, and this is where you advance to the next state. And you say set the LEDs to be the next LED and set the state to be the next state. And so since I have a default setting, this should compile and I should be able to run it. It just means if I go to any of the states that I haven't defined, then it's not going to do anything yet. So let's see if it actually compiles. How many emails do you think I'm going to get that ask, what do you do with the things that are commented out? I always get emails like, oh, I did everything except for these last little parts. Okay, so any questions while it's busy compiling?
I mean, you're compiling and you also have missing steps, so why?
So why is it going to work if I'm compiling it and I have missing steps?
Well,
It's not going to completely work.
Yeah.
Floor 1 will work because I have floor 1 complete. And if you go anywhere other than floor 1, all that's going to happen is it's going to go back to floor 1 because I have my default to be go back to floor 1. So I'm just showing you that the logic works, that the technique works, but that in general, you know, there's other parts to fill in. And so if this compiles and runs, we should see it work correctly for floor 1. Any other questions? Yes?
I'm sorry this is like dumb, but you said for like the beginning when you like output right and it's 10 to 7, that's just from the constraints. And that's where you got those numbers.
Yes, and you absolutely don't have to do it that way. That's my laziness. Yeah. And it turns out that the way I did it, it could have been 430 or 40 because I never actually used those numbers. I thought I might, but I didn't. Yes.
Why are we using switches instead of buttons for the floors? Just like a random question. Well, actually, never mind. Now that I think about it, it makes sense.
Well, it's because so you can see it and so it stays on.
Yeah.
Yeah.
Oh, okay.
And so it's like, so the clock doesn't advance until you press the clock button.
Mm-hmm.
So in between clock cycles, you can say, okay, I want to set floor 1. No, I want to set floor 2. And so you can, you know, just set them how you want them.
Okay.
Or we're just missing floor 2 and 3?
2/3 of it, yeah. And I'm not missing all of floor 2 and 3. I'm missing, I'll show you what I'm missing.
Okay,
So-
yeah, I appreciate that.
So I'm missing, so I have, and I'll tell you basically what's, so I have regular floor 2, which if you don't try to do all my fancy stuff, that might be all that you need. So regular floor 2, but then I have, what I don't have is if you are on floor 2 going up, what do you do there? Well, basically you do the same thing as if you're on floor 2. if you just copied exactly what floor 2B was here, it would run. You wouldn't have any problem. And then, so let me just repeat that. If you copied exactly what I had for floor 2B right here for floor 2B up and floor 2B down, it would run. You wouldn't have any problem. It wouldn't have my extra logic in there of, you know, holding on to the fact that you were going up or down. Floor 3B and you're welcome. Floor 3C, that is a little bit different, and that the main thing that's going to be different between floor 3B and floor 3C is whether the door is open or not. And so in floor 3C, the door will be closed. But this is where you have to do the logic to decide what do you do where do you go from floor 3? So floor 3B, if you say, if switch 2 is on, go to floor 2. If switch 1 is on, go to floor 1. If switch 3 is on, stay on floor 3, you'll be set. Okay, right, bitstream complete. All right. Okay, so right now I have no switches set, and so I don't know what'll happen if I press the clock button with no switches set. It does my default. So if you want to come over and look and see what it's doing.
Can you show how well, never mind.
So what this is showing, this is the LED for floor 1, floor 2, floor 3, and door open. Mm-hmm. So my default is if you don't know what else to do, go to floor 1 and have the door open. Okay. So now these are the switches for 1, 2, and 3. So if I set the switch for 2, it should on the next clock cycle stay on floor 1 because it's supposed to stay there, except it didn't.
So in the lab, are we going to be the ones to show them, or are they going to test it out?
You're going to show them, and then they're going to ask you to show something. Why did it? I don't know why it went to floor 2. I'll have to think about that. So it went straight to floor 2. It's probably because I was not really on floor 1 to start off with. Okay, so now I'm on floor 1, and stays on floor 1, and now the door closed. And now will it go to floor 3? It goes to floor 3. It goes to floor 3 after clock cycle. So it's not perfect. Not everything is set. So I just told it a state that it didn't know, so it went to my default. Mm-hmm. But that's the idea. So what's usually happens, they ask you to demo it. And so you'll say, okay, well, here's how it works. I'm going to tell it to go to floor 1, and there it's on floor 1, and then it'll stay there for a clock cycle, and then the door will close, and then you'll say, and now I'm going to tell it to go to floor 2, and it'll go to floor 2.
How do you prove that it stays open for 2 clock cycles?
Well, it didn't. So what? Here's how it should work. It did earlier, but I changed some of the code so it didn't work. So here I'm on floor 1. If I press the button again, even if I set switch 2, it should stay on floor 1. Oh, it did that time. And so it didn't go anywhere. And now if I press it again, it goes to floor 2.
Okay, gotcha.
Yeah,
Gotcha.
yeah. So that's how I showed it.
Okay.
Yeah.
Can you show where this is floor 1, right?
Mm-hmm.
This is floor 3?
Actually, I think that's floor 2. Yeah, that's floor 1.
Okay.
And that's the door open.
It's the door open.
So if I stay on floor 1, with no buttons pressed, the door closes.
Oh, so that determines if the door is open or closed.
That one right
Yeah.
there,
Oh.
the fourth one.
Okay.
So that's floor 1, that's floor 2, that's floor 3, that's door open.
Okay. So if it goes to the second door, the second LED right here should be opened.
So, yeah, so if I go to floor 2, the door should open, and it does.
Okay, that's door open, second floor. Okay.
Yes, right. And then if I stay on floor 2, it should stay, it doesn't, that's a default because I don't have that one set.
Okay.
Yeah.
Usually people uses these beside
Yes.
this.
I like this one because these sometimes it's like it double clicks.
Oh, yeah.
Yeah.
Okay, got it.
If that were to happen in the lab,
They did it, that's fine. I mean, just tell them, yeah.
And what days do we have? I know like Tuesday is when we have to present our project, but like what?
I didn't know that, so I'm glad you told me that because I didn't know that.
Next Tuesday. No?
During the week
Is it
I
not?
thought it was during the final. Well, I mean, I guess not. But no, because that would have to be like a scheduled thing. We don't have like normal classes. So during our next.
It's in the lab.
That week, yeah. Okay.
So, and is that the week after Thanksgiving?
Yes.
So usually what that means is I'm usually here on Sunday and Monday for people to test things out.
Sunday.
Yeah, because I'm a good person.
Oh.
So usually, if people ask, if no one asks, then I won't be here. But
Wait, what time do you think Sundays?
it depends on my schedule and whoever asks me, whatever.
Whoever asks.
Yeah.
What did we ask like right now?
Then I can put it on my calendar and I can plan to be here.
Yeah.
So if there are no other questions except for scheduling, I'm gonna stop the recording. Are there?
I'm sorry.
Yeah.
So your default is like one of your, like the floors.
It's a
Basically, so
state.
it's within your first always.
Right,
Okay.
and the truth is, it should never actually go there.
Okay.
That's to keep Verilog from yelling at you, and also just to keep it, to debug it, kind of like I'm doing right now. It's like, okay, I can test out what I've done
Yes.
without having everything set.
Okay, gotcha.
But it keeps Verilog from fussing, because you could say, well, it's just don't care, I'm never going to have, I'm never gonna set switch 1, 2, 3, and 4, but,
Okay.
yeah. Okay, other questions?
I have a question
Yes.
about your clock cycle. Did you
Yes.
use a switch or a button for a clock cycle, or is it just?
I used this button, I think you came in late, so,
Yeah.
yeah. So what I did, so I have, in my constraints,
Mhm.
this is what I use for the clock, is this code right here,
Mhm.
which goes along with this little extra button module, which they have in the lab,
Mhm.
and it plugs into the top row, and it's this button right here,
Mhm.
and I just like it because it's more reliable. But you could also use one of these buttons,
Okay.
and that's the clock cycle. And so I have it set right here with the name clock, and then in my main I have clock as an input and as an input.
Okay. And I have a question about not really scheduling, but getting help. If I write my Verilog code and then I see that there's something wrong with it, but I can't figure it out, can I send it to
You can send it to me,
Okay.
and I'll do my best. Yeah,
Okay.
you can also use a switch for the clock.
Okay.
And so the switch, and so since it's on the positive edge of the clock, it operates when you flip it up, and then when you flip it down, nothing happens. You flip it up again, something happens.
Okay.
Yep.
All right. Thank you.
Okay. Any other questions?
I asked about my states, but it's not.
Oh, okay, all right, I will